Today we're going to be talking about 4 operations involving scientific notation. Now, you might also see scientific notation listed in your book as standard form. For the purposes of this discussion, though, we're going to be talking about scientific notation and the operations used in order to, when working with scientific notation. Now, we use scientific notation when we want to deal with numbers that are very, very large in scope or very small. You're going to see a list of many of the different powers of 10. You certainly don't need to memorize all of them, but there are some that you really should know by now, and you'll see them when they pop up here in a moment. So before we start talking about the operations involving scientific notation, we're going to do a little rewind and just specifically talk about scientific notation. Now, in scientific notation, you have some value. In this case, we're going to call it C, and it's going to be multiplied by 10 to the nth. And that n represents on depends on how large or how small the number is. The one thing that's very important about the C value, it has to be equal to or greater than 1, but less than 10. If it is not in scientific notation. Also, what we need to understand is that n must be an integer, so you cannot have any fractions in the n value. Because what happens then? Well, then it goes back to what we were talking about yesterday in class when dealing with fractional indices. And you don't want to mix up fractional indices and scientific notation. It's a world of chaos. So some good examples of values in scientific notation. 2.3 times 10 to the 4th. This is a value in between 1 and 10. Well, greater than or equal to, in this case greater than. This is an integer. 9.8, again, less than 10, still okay. Still okay. All right, examples that aren't very good or that are not in scientific notation. This value, 45.8, is not a number between 1 and 10. And over here we have a fraction as a value in scientific notation. So the quick and dirty rules of scientific notation conversion in case you haven't been working with scientific notation much. Again, part of our little rewind here. If n is positive, so n referring to my index here on the 10, then what you're going to do is move the decimal to the right. If it's negative, what you're going to do is move the decimal to the left. So here's how you convert from scientific notation to regular notation. Right here I have 3 examples. You could probably do these on your own. Or you could just look and see how the conversion goes. So you can see 1.34 times 10 to the 4th. If I started, here's how I can do a quick check. Have my decimal at the end, 1, 2, 3, 4. And I see I've moved it back to 1.34 times 10 to the 4th. 5.6 times 10 to the 7th. So we're looking at where my decimal's going to go. If I started here, 1, 2, 3, 4, 5, 6, 7. And then my number is 56 million. And then 7.3 times 10 to the negative 5th. So in this case, I'm getting a lot smaller, 10 to the negative 5th. But still, I want to make sure that my number ends up being between 1 and 10 when converting from one direction to the other. 1, 2, 3, 4, 5. That's how many times I had to move the decimal in order to get to a value in scientific notation. So now that we're there, let's go back to talk about the big 4 of operations. First, we're going to be talking about multiplying in scientific notation. So for example, if you had 1.4 times 10 to the third times 7.6 times 10 to the fourth, these are pretty large numbers. You don't want to do this number out by hand. There's going to be a lot of zeros. Eventually it'll lead to a lot of crying. So let's use scientific notation, and it's actually pretty easy if you remember to multiply the numbers and powers separately. So I'm going to multiply 1.4 times 7.6. That's going to get me 10.64. Hold on, I know what you're thinking, but wait for a minute. Then I'm going to multiply 10 to the third times 10 to the fourth, and we know we have similar bases. So what I end up doing is adding the indices together to get 10 to the seventh. So the laws of indices still apply. All right, but I'm not done, because if you're looking at the 10.64, you're saying that is not a value that is equal to or greater than 1, but less than 10. So what we're going to do is change the first number to meet the restrictions. So I'm going to change this 10.64. I'm going to move the decimal over. Now I've subtracted a power of 10 over here on the left side, which means in order to keep things balanced, I have to add a power of 10 on the right side. So you'll notice now I have 1.064 times 10 to the 8th. Subtracted a power of 10, added it over to this side. Now let's take a look at division. So the rules are generally the same here. I have 1.2 times 10 to the negative first divided by 4.8 times 10 to the negative fourth. So now we're dealing with smaller numbers. What I'm going to do is divide the numbers and subtract the powers. So first I'm going to take 1.2 divided by 4.8. And if you can tell, you can see that that's 12 divided by 48, which is 1/4, or 0.25. And then I'm going to take 10 to the negative first, and I'm going to divide it by 10 to the fourth. So the rule here, when you're dividing similar bases, remember you need to subtract the exponents. So that means 1 minus a negative 4, which gets me a positive 3. But again, if I look at the first number, 0.25 or 25 hundredths, that is not in between 1 and 10. So what I need to do is change the number, the first number, to meet the restrictions. So I'm going to move the decimal spot over 1. Now in this case, what happened? Did I add or did I subtract a power of 10? Well, to change it from 0.25 to 2.5, I added a power of 10. And remember, things must be balanced, so I have to subtract a power of 10 from this side. So now I have 2.5 times 10 to the second. All right, so far so good. The last thing I'm going to talk about is addition and subtraction. Now I'm lumping them together because the idea is generally the same. If you don't want to look at the answer, let's just go ahead and cross those out. You wanted to go ahead and figure out how things work. Well, you know what? Odds are you probably just paused the video anyway. So you saw the answers. We'll just keep them there. All right. So let's say, for example, I have 4.3 times 10 to the fourth plus 5.2 times 10 to the first. 10 to the fifth, sorry. The first thing I need to make sure to do is to have them both in the same base 10. So notice I have them set up as 10 to the fifth and 10 to the fifth. I had to change 4.3 in order to be able to add the two values together. Could I have changed 5.2 to make it 10 to the fourth? I don't know. We'll talk about that. Maybe you should think about it. Try it, changing it the other way, see what happens. But anyway, I have 10 to the fifth, 10 to the fifth. So now what I'm going to do is add together those two C values. Now I have 0.43 plus 5.2. That gets me 5.63. Since I know I'm adding together values that are 10 to the fifth, I know I'm still going to leave my answer in terms of 10 to the fifth. Same thing with subtraction. I have 9.27 times 10 to the negative 7th and 1.68 times 10 to the negative 8th. Which value is smaller? Note the silence. Here's where you think about which value is smaller. All right. So what I'm going to do is change them both to 10 to the 7th. So I have 9.27 times 10 to the 7th. That remained unchanged. But instead of 1.68 times 10 to the negative 8th, I'm going to change it to 0.168 times 10 to the 7th. Now that they're both in the same base values, I can go ahead and subtract 9.27 minus 0.168, and then I get my answer of 9.102, and my base remains the same. So what you're going to have to practice if you're not very good at this concept is making sure that when you change powers of 10, that you change them appropriately, because here's where you can make your mistake. After that, you're adding and subtracting. And I know you are all Vikings when it comes to adding and subtracting. That's all for now.